So in addition to y equals mx plus b, that's the slope intercept form. This is the point slope form. We don't have the y-intercept here. And it is this equation, y minus y1 is equal to m times x minus x1, where x1, y1 is a point on the line somewhere. M is the slope, and then the planal y and the planal x just stay as a y and an x. Right, here's the formula. This is x1, y1, and this is m. So we plug those in. y1 is -2, m is 1/4, and x1 is 3. The only thing we have to do is fix this. And remember, double negative is a positive. So y plus 2 is equal to 1/4 of x minus 3. And you can leave it just like this. You don't have to do anything with it yet. To graph it, it's sort of this, it's the same process as graphing with the y-intercept, except instead of starting at the y-intercept, you start at 3, -2. So 3, -2 is my starting point. That's one. Step 2 then is to count the slope from there. So our slope is 1/4, so we're going to go up 1 and then over 4. So up 1 over 1, 2, 3, 4. Or if you wanted, you could go backwards and go down 1 and then back 4. Down 1 and then 1, 2, 3, 4. Once you've got all your points, we come in and we connect our dots. Putting this into point slope form is x1, y1. So y minus 1 is equal to -6 times x minus -2. I had to deal with that minus and negative. That's really the only thing you ever have to change on these so far.
I'm sorry, but is -6m?
Yes.
Okay.
Sorry about that.
Do you not know how to read?
I just wanted to make sure.
Guys, be nice.
I was just kidding.
I know. Okay, so to graph it, we start at -2, 1. And then our slope is -6, so we go down 6 over 1. So we're starting at -2, 1, and we go down 1, 2, 3, 4, 5, 6, and then go over 1. Okay. If you say slope-intercept form, so if you're asked for slope-intercept form, it's y equals mx plus b. If you're asked for point-slope form, should I put the point form there? It's y minus y1 is equal to m times x minus x1. Okay, the first step is the same on both. And of course the slope is m. Okay. Here's where it gets a little different. In slope-intercept form, you plug in 1 point and m and solve for b. And then you plug m and b into the formula. On point slope form, you pick a point and you plug it in and then you're done. So far. Okay. You could be asked to take this and then convert it, in which case there would be more steps. But we're not there yet. All right, well, they'll talk about standard form of an equation, and the way it works is the standard form of an equation is ax plus by equals c. A, b, and c have to be integers. So you have no fractions or decimals. Okay, so A, B, and C are just numbers. And A must be positive.
Is that a minus C?
Equals C. Oh, this is and.
Okay.
I could do the other and. Hold on. See if I can remember how it goes. Is it like that?
Yeah.
Okay. So A, B, and C have to be integers, and A has to be positive. B and C don't have to be positive, but A has to be positive. That's standard form. So it would look something like 2x minus 4y equals 13 or something. That's standard form. So we can take this and put it into standard form. Okay, so step 1, I'm going to clear the fraction. And in order to do that, we're going to multiply by the denominators. If there's more than one fraction, it would be the common denominator. Okay, so my denominator in this case is 3, so I'm going to multiply this by 3, and I'm going to multiply this by 3. Now what's important here is I'm multiplying this whole expression by 3, but it's really only multiplying by the 2/3 because this is 3 times 2/3 times x minus 5. So if you multiply the x and the 5 times 3 also, it's really multiplying those by 9 because you're multiplying it by 3 twice. So we distribute in this 3 to get 3y minus 3. And here, that 3 and that 3 will cancel each other out. And so I'll get negative 2 times x minus 5. So then I'm going to distribute this negative 2. And it's the negative 2 that gets multiplied in, so I don't lose the negative. So it's 3y minus 3 is equal to negative 2x plus 10. of it. Alright, I need to get this 2x over here in front of the 3y. So I'm going to pick it up, and I'm going to move it. And when I do that, I have to change the sign, because I picked it up and I moved it to the other side. So we're kind of doing the opposite of what we did before. Whereas before we picked up x and put it on the right, now we're going to pick it up and put it on the left. And then I'm going to add 3 to both sides. And now I am in standard form. So one other step, if x is negative, we need it to be positive, so you change all of the signs. And I will give you an example of that. I just want you to have this step. We don't have any fractions, right? Oops, wrong color. So I can skip that step and go straight to the distribution. So I'm going to distribute in this 7. Okay. So I've got y plus 3 is equal to 7x minus 14. I'm going to pick up this 7x, and I'm going to move it in front of the y. When I do that, I have to change the sign. So I have negative 7x plus y plus 3 equals negative 14. I'm going to subtract 3 from both sides. Negative 7x plus y equals negative 17. But I'm not allowed to have a negative here. So I change all of the signs. So this becomes 7x minus y equals positive 17. Essentially, what you're doing is multiply everything by negative 1.
I hate these negative and positive numbers.
Convert from here to here. So step 1, we want to distribute okay, so we take that and we multiply it in, and we get y plus 3 is equal to 3 halves x plus 3 halves. Now we can clear the fraction if you want to clear that first, and then you end up having to divide by it again. If that's, I'll show you that way as well. Step 2. We need to find the common denominator and convert the numbers to match. Gosh, that's not going to make a lot of sense, is it? Okay, this is 3 halves, right? So I want this to be halves. So 3 equals something halves. 2 times 3 is 6. So 3 equals 6 halves. So y plus 6 halves is equal to 3 halves x plus 3 halves. And then I subtract or add. And we are now in slope-intercept form. We can do that without using the fraction. We can clear the fraction first. guys really just absolutely hate fractions. I'm going to multiply everything times 2, because that's my denominator, right? And this 2 and this 2 will cancel each other out. So I get 2y plus 6 is equal to 3 times x plus 1. So 2y plus 6 is equal to 3x plus 3. Subtract 6 from both sides. Come up here where I have more space, and I get 2y is equal to 3x minus 3, and then divide by 2. So whatever you multiply by to clear the fraction, you're going to end up dividing by. So you can do this either way. You can either work with the fraction, or you can clear the fraction, and then you end up with them back. Yeah.
How did you cancel out 2, like 3 over 2?
Here?
Yeah.
Oh, here?
No.
Here.
No.
Here.
Here.
She did.
Or like the other one in the box.
This one?
Yeah.
I did times 2. So the 2's here canceled. So I multiplied both sides by 2. And so these 2's canceled, and then this 2 got multiplied in. And so these cancel, so you're left with a 3. And then I multiply in the 3 to get the 3x plus 3.
So like anytime that there's a fraction, you just put like whatever number.
You can multiply by the denominator.
Okay.
And I'll clear that they cancel each other out. Because denominators are division. So this is divided by 2 times 2. And so they cancel.
Say if it was like 4 over 3.
You'd multiply by 3.
Yeah, you can put the 3, like where you put the.
Here, hold on. So if I had something like 3 or y plus 3 is equal to 4/3 times x minus 2, and multiply both sides by 3. These 3's will cancel.
Got it.
Got it? Okay. So you guys want me to finish this one so you can see what it looks like? No? Okay. Oops. You don't have a fraction. That's nice. So you just distribute the 3. It's a negative, so you have to distribute that negative in with it. Darn it, that's supposed to be an x. Plus 12. And then subtract 6 from both sides. And you're done. The point of turning it from a point slope form into slope intercept form is that this tells me my y-intercept. That's the only thing that's the only benefit is now I know the y-intercept, whereas here I did not know the y-intercept.